Okay, so the graphs of functions. So when we talk about a linear function, this is going to be a line, okay? And it's usually written in the form of the function f evaluated at x is equal to ax plus b. Now, a and b are going to be constants. And when we talk about this form, we can identify certain pieces of it. So this is in mx plus b form, okay, or ax plus b form. A is going to represent the slope of the line. Okay, A is going to represent the slope of the line. And B is going to represent the y-intercept. Okay, so if you've had experience in graphing lines, you can do this in two ways. You can graph a line by using the slope and the y-intercept, or you could graph a line by plotting points. Okay, so either one would work. Let me do plotting points first, and then we'll do the y-intercept and slope. Okay, so if we were to plot points, okay, what that means is I'm just going to substitute in values for x. So we've talked about domain and range. What kind of function is this linear function? Is it a polynomial? Is it a rational function? Or is it a square root? Polynomial, right? So our domain is all real numbers. So what that means is I can substitute in anything I want to for x. So I usually try and pick one or two negatives. 0 is usually easy to plug in, and then maybe one or two positives. So I'll substitute in, let's do -1, 0, 1, and 2. Okay. Technically, all you need are 2 points to graph a line, but you can always plot a few extras just to make sure everything is good to go. Okay, so I'm going to evaluate this function at each one of these x values. So I'm going to start by evaluating the function at -1. So when I evaluate a function, I'm substituting that value in for the placeholder of the variable x. So we have 2 times -1 minus 3. Okay, so that's going to give us -2 minus 3, which is -5. So what we're going to have is actually the ordered pair, -1, -5. The ordered pair, -1, -5. Okay, I'm going to do the same thing for each one of these. So for 0, I'm going to substitute in 0 for x into the function. So we're going to have 2 times 0 minus 3, which is -3. Okay, that gives us the point 0, -3. Substitute in 1. So we're going to evaluate the function at 1. So 2 times 1 minus 3 is going to be 2 minus 3, which is -1. And so we have the point 1, -1. And then 2, when we substitute that value in, 2 times 2 minus 3 is going to be 4 minus 3, which is 1. So we're going to have the point 2, 1. Okay. So this is called the Cartesian coordinate system. The horizontal is your x-axis, the vertical is your y-axis. This point where the two number lines intersect each other, that's going to be the origin. So that's the point 0, 0. So when we graph, it's kind of like Battleship, right? You go left and right and then up and down. So to plot -1, -5, we're going to start at the origin and we're going to go to the left 1 and then we're going to go down 5. Okay, so -1, -5. And then we have the point 0, -3. So 0, -3 is going to put us on the y-axis. It's actually the y-intercept. Okay, then we have the point 1, -1. And then we have the point 2, 1. So I'm going to go to the right 2 and up 1. Notice that all of my points line up to form this line. And so to complete the graph, I just draw on the line. and there's the graph of my linear function. Okay. If we were to use slope and y-intercept to graph this line, then we would start with the y-intercept. So we know the y-intercept is going to be -3. We found it in our points. We can also identify it from our function. And then from that y-intercept of -3, I can use my slope of 2, rise over run, to go up 2 over 1. So starting from the y-intercept, I can go up 2 and to the right 1. And because slope measures the steepness of the line or how the line changes, I can do that from any 2 points. So from that point, I can go up 2 over 1, up 2 over 1, up 2 over 1. I can also think about slope as being -2 over -1, right? That still makes a positive 2. So from the y-intercept, I can go down 2 to the left 1, down to the left 1, and so forth.